All right, welcome to this exploration about algorithmic design. First of all, I just want to see some hands. Are any of you using OKLCH today? Anyone? Yeah, some of you. Great. Elsa. Woo. That's one of the topics we're going to touch upon. As was already mentioned in the introduction, I'm a tech lead and design lead in the Equinor design system. I started my career as a typographer almost, actually it's exactly 30 years ago when I was finished with my apprenticeship. And I kind of fell into web development and web design almost by accident. At that time, when I met a friend of mine who in the street, and he said, "Oh, so have you checked out this new internet thing?" And I said, "Internet?" And he said, "You're not on the internet?" And then I had to go home and find out what that was. And then shortly after, I got a question from somebody who asked, "Can you do a course in HTML?" And I said, "Yes, of course." And then I had to go home and find out what this HTML thing was and learn that before the course. So since then, I've been mainly working with design and code, most of the time in combination, but always with this topography background in the back of my head. So with the introduction of CSS in 1996-97, we could finally start doing at least some topography on the web. Prior to that, the default font size was 12 pixels on a Mac, 16 on a PC, and there was nothing you could do about it. So during these years, it's been a pleasure to see how CSS has evolved into the powerful tool it is today. We actually have functions in CSS too now, so it's becoming more and more like a proper programming language. All right, so what I'm going to talk about today is topography from an algorithmic design perspective, meaning generating typographic scales. We are going to look at spacing ratios, and we are going to look at generating color scales using OKLCH, and also touching upon using APGA for contrast checking. Anyone using APGA today? Yeah, great. Wonderful. All right, so let's start with a topographic scale then. Some years ago, I stumbled upon this article by a designer called Spencer Mortensen. I don't know if you can see the text, but there are some screens, hopefully, in the back there. In this article, he is comparing the original typographic scale that the old typographers used in book print for centuries with Western musical theory. And since I'm also a musician, of course I found that very intriguing to find out what was that all about. So this is the classic typographic scale. This is what we used, or what they used back in the day when we had movable type to make books in print. And what Spencer Mortensen did was that he saw that there is a pattern here. And by the way, this is based on points and not pixels, right? So the default font size when you use Pika points or Didot points is 12 normally for body copy, while it's 16 on the web. So he noticed this pattern with these recurring numbers. And he said, this is just like octaves in musical theory. Are you familiar what octaves are? Yeah, so if I'm talking like this, and I'm talking like this, then it's the same tone. It's just one octave up. There are more vibrations per second. So he found out that the formula for this topographic scale is actually this one, and it looks maybe a little bit strange, but we'll deconstruct it. And he found out if we use this formula to create a topographic scale based on Western musical theory, And then we have the octaves, which I just showed you, which are the repeating numbers, 6, 12, and so forth, 24. And then we need the notes between those octaves, which will then be the steps in the scale. So in Western musical theory, we have 12 notes between 2 octaves. In India, I think they have 64, if I'm not mistaken. In this classic typographic scale, his calculations was that we had 5. And the way that can be expressed is simply if we start with 16. Can you see that, or is it too small? All right. So if we start by 16, then we multiply that with the ratio, the octave, and then to the power of 1 divided by 5, then we get the next step in the scale. If we add 2, then we get the next step, and so forth. So that's how we can build a typographic scale. And then going downwards, we have the same system. Now, as you can see, we get a lot of decimals here. Some people have a problem with that. So we can round it and do this. So now it looks a little bit better. Now we have 14, 18, 21, and so forth. The problem, however, is when we get down to the smaller sizes. Do you see the problem here? Right? The increment between 9 and the next steps should be smaller than the next step and the one after that. But in this case, we go from 9 to 11 and then 12. So one thing that we did in the Equinode design system is that we rounded off to the nearest half pixel. And I'll show you very quickly what that looks like. So the way this can be expressed in CSS, and now I guess I need to zoom in a little bit, is if I declare a variable that I call base, which is 16 pixels. And then, as I mentioned, the next step will then be, let's call that large. And then we will calculate the base like that with 2 to the power of 1 divided by 5. And then we can then round that off to the nearest half pixel. So I've cheated a little bit. So this is a finished example of that. So you can see that in this case, the first step will be 9. The next 10.5 and then 12. Because 10.5 is in the middle between 9 and 12, right? And then 14, 16, 18.5, 21, and so forth. So by introducing decimals, we get a more harmonious typographic scale, which fixes that problem in the small font sizes. So that's actually what we use to generate the typographic scale in the Equinode design system. And then we get to line heights, which I think is also always interesting, because there is a misconception going around when it comes to line height and accessibility, which is this one. What should the line height be for a body copy? And then everyone is going to say 150% or 1.5 m, right? But is that what it actually says in this success criterion? No, it's not. It says if the end user changes the line height or the font size in his or her browser, then nothing should break. The product, the application, or the website should still be usable. So that doesn't mean that everything has to be 150%. It just means that if someone is using 150% and overriding our style sheet, then it should still work. So let me show you an example of that. In this case, how many lines should we have in a button? 1, yes. What should we do if somebody adds 2 lines of text in a button? Should the component break? Or should it be flexible enough so that if someone does that, then it should still work. This is what it says in the WCAG success criterion. The component shouldn't break, it should be flexible. And this is also another principle that we use in the Equinor design system. We don't use heights in components. The height is also always a summary of the height, of the computed height of the text box and the padding, the vertical spacing. But as you can see, the line height that I have here is quite compressed. So this is quite far from 150%. Which brings me to another point. Which is that sometimes you need a more compressed line height when you have components with just 2 or 3 lines of text. And sometimes you need a more spacious line height when you have paragraphs of text, body copy. So this was before we had AI agents that helped us with coding. But in this case, we experimented with using easing curves for the line height. Because what you usually want is a more spacious line height when the font size is small, but as you increase the font size, you want to decrease the line height proportionally, right? Which is what you can basically do with this curve. So this is with the help of Claude, which is much more pretty to look at, and then a Google sheet. So in this case, I have the normal line height, which is starting at 139% in the smaller sizes, and then it's gradually decreasing to 110% in the large sizes, following these curves. So you can see that when I change the slider, then you get the font size, the line height, and also the ratio. And then I've also added the squished line height for those more compressed situations. Another thing that we do is that we use a 4-pixel grid, and I think that's quite common by now. It used to be 8, now it's 4. So we also align the baseline of the text to that 4-pixel grid. And as you can see, when we do that, this beautiful curve down here is not so beautiful anymore. But I think this is a trade-off. If you want to have that perfect vertical rhythm that we'll get into in a second, then you need to make some compromises. So even though the starting point is the Bezier curve, ease-out cubic curve, then I think it's acceptable that we deviate from that when we align it to the 4-pixel grid. Which brings me to another point. Baseline grid alignment. That's something that we used to do back in the day in InDesign and Quark Express before that. I don't know if you remember when newspapers were published on paper. Yeah. And if you read an article that spanned several columns, I don't know if you noticed, but the lines in those columns were even. They had the same vertical placement, right? They didn't jump up and down. And that's because the typographer that made that article made sure that the text line was vertically aligned and that the text was locked to the baseline grid. That's something that's been very difficult to do on the web up until recently. Now we can, because of something called text box trim. Anyone using Figma here? Yes. So we have a similar feature in Figma called vertical trim. And Figma in this case was actually, they released that feature almost a year before you could actually start using it in the finished product, which I think was interesting. But with a combination of vertical trim in Figma and some new features in CSS, we are able to achieve this baseline grid alignment now on the web. Another thing is, let me just show you some examples of that, by the way. Because this is what most people are doing. And I don't mean that as a criticism. It's just common to most design systems, or most designs actually, are using something called soft grid. And soft grid means that you measure the distances between the text boxes. So in this case, we have text frames that are 20 pixels, 16 pixels, and then we have a gap of 12 pixels, and everything looks very neat, doesn't it? At least until we remove those text boxes, because they don't really exist in the end product. It's just something that helps us to create the layout, right, and the tools that we use. So in this case, you can see that the actual distance between the baselines is all over the place. So does this actually create a good vertical rhythm? I don't think so. I think what we need is something like this, where the baselines of the text are locked to the 4-pixel grid. So this is what you actually perceive when you look at the web page, because you can't see those invisible bounding boxes. So that's what baseline grid alignment should look like. And then we get to this topic, which is optical alignment. So if I turn off these helper lines, what do you think of that icon on the left delete button? Does it look like that's aligned? Or does it look like it's a little bit too much to the right? Yeah. And what about this button? The close button, is that aligned? No, it doesn't look like it. But if I turn on the stroke, is it aligned now? The problem is, in this case, I have a close button with a hover color, right? But you can't really see that hover color until you move your cursor over the button. So what you need to do then is to make sure that the button is aligned in its idle state. So that even though, in this case, let's see, if I turn off on the stroke again, even though in this case on hover, the circle will not be perfectly aligned, I think the most important thing is not those 150 milliseconds before you click, but this. This is what's important. This is what should be aligned. And the same thing with the button and the icon, right? So in this case, it's moved slightly to the left of the margin, which means that if I turn off these lines, then it should look like it's more aligned than this one. Do you agree? Yeah, good. So, and also in this case, I've used the compressed line height, as you can see. Yeah. One thing that's very important, I think, and also one of the learnings that we did in our team, especially the last year, is that Figma is not the end product, right? So even though we make something pretty in Figma and we polish it and everything is pixel perfect, that's not the product that the end users will interact with, right? They will interact with the product, the web page or the web app in the browser. Which is why we have started to do prototypes and mockups in CSS and HTML before we move to Figma. And also, when we solve problems, when we add new features or change design in the team, we pair up a designer and a developer who solve the problems together, instead of designers solving it first and then handing it over to the developers and then hoping that it will be fine. Because the issue is that the features in CSS today are so powerful that you cannot recreate that in Figma. Yeah, and you also have, for example, units like M, which is relative to the font size, right? So if you have for example, a button where the distance between the icon and the text is based on M, so it scales with the font size. You can't do that in Figma. You need to calculate the numbers. So it's better to explore what you can do in CSS first, and then implement that or copy that into Figma as best you can. And in some cases, you need to make some calculations in Figma that you will not use in code, because there are better ways to do it with CSS. So this is the typography system that we have. As you can see, you can change the font size. We are using a data attribute for the font size, which corresponds to a variable mode in Figma, and I'll show you that later on. So that means that when the designers work with components in Figma and they are changing variable modes, the developers just need to use dev mode in Figma to inspect the value of those variable modes and then use the corresponding data attributes in CSS or in HTML. So in this case, we have the normal and squished line heights. We have the data font size, and we also have, as I'll show you a little bit later, the option to either lock text, align text to the baseline grid, or in some cases to choose to not align it to the baseline grid. So with the use of text box trim, as you can see, maybe that's too small. I can try to zoom in a little bit, but I'm not sure if that will help. Let me check. No, this box is still too small. So you just have to take my word for it that all of these text boxes are multiples of 4 pixels. No matter what the font size is and the line height, the text boxes are 8, 12, 16, 20, and so forth. Which means that it's much, much easier to design things, because whatever you stack on top of each other, it will always be multiples of 4, which means that it will always be aligned to the baseline grid. All right, let's talk about spacing ratios. And this is another concept that we're using, which is, as you can see, we have, in this case, some very rough sketches of a tab, a text input, a button, and a chip. And we have some ratios also defined. And what does this mean? So the point here is that when you create something, when you create a component, there is always a ratio between the horizontal and vertical padding, spacing, right? If you have the same horizontal and vertical spacing, then we call that squared. If you have less vertical spacing than horizontal spacing in a button, for example, we call that squished. So imagine that you have a button between your thumb and your index finger and you squeeze it. And then we have the text input, which is stretched. So then you stretch the component or the text input vertically, and you get more spacing vertically than horizontally. So the way this works then, let me see if I have time for a quick demo. I think I have. So in this case, we have the topography component. So let's say that I'm going to create a button now. I just want to show you briefly what that looks like using this system. Create an auto layout. And then the first step in the process is to bind the properties to the variables. So I start with selecting the icon, applying variable, and then I have a variable called icon size. And you can see that the number is a bit strange, 15.75, which is because the height is calculated based on the font size. And then I have the gap, which is going to be the same. Let's see, gap 6.5, which is actually the font size multiplied with 0.618, which some of you might recognize, the golden ratio. And then we have the horizontal padding, and we have the vertical padding. And then I'm also going to add a container for the icon, because I'm going to put that into an icon container like this. And the reason I'm doing that is that so the icon itself doesn't take any space vertically, right? So that means that it doesn't interfere with the calculations. So now I've bound all the properties to variables. The next step is then to choose, and this is where the actual design work happens. So I want a font size of medium, and I want a line height of squished, just in case someone adds another line of text to this component. And then for the ratio, since this is a button, I want the squished version or variant. And then for the padding, I want medium. Let's see. Yeah, and the font size. The font size, yeah, I chose that already. All right. So there you have a button. And I'm going to add some helper lines to that. And as you can see, the helper lines they're also aligned with the variables. And then I need a stroke. So I'm going to add a stroke of 1 pixel. And then also the radius, as you can see. So that's all you need to build a button. If I copy that and I change some of these numbers, let's say I want the extra small padding, I want the small font size, and I want, let's see, the border radius to be a pill. Now you have basically a chip, right? There is one thing though. You can see that even though the text is aligned to the baseline grid, in this case, if I turn off the helper lines, it looks like the text is too low, which means that we can't always lock the text to the baseline grid or align the baseline grid with the layout grid. In some cases, where we have just one line of text, it's good to have the option to turn that off, which we also have. So using this system with the topography and the spacing ratio, you can build basically, I won't say anything because then somebody will prove me wrong, but most things. You can build most things. Trust me, I've tried. I've even tried to rebuild the interface in Figma, some of the parts with this system, and it works. And then we have the implementation in code. I really like these layout lines in Figma, so I've replicated those in CSS as well. So in this case, if you add data debug to the component, then you get these helper lines. But as you can see, the rest is the same as what I did in Figma. We have the font size, we have the ratio, we have the padding, yeah, and we have the data off-grid, as it's called, where we allow the text to be centered vertically instead of being locked to the baseline grid. All right. Then OKLCH in APCA. This is the color system that we built in the EDS. For those who are not familiar with OKLCH, OKLCH is a color mode. It's a perceptual color mode, meaning that it's built on how the human eye perceives color and lightness. So that means that if we compare the OKLCH colors with a lightness of 50% with HSL with a lightness of 50%, do you see what happens when I turn off the colors? So in HSL, yellow and blue are perceived as vastly different colors when it comes to lightness. We perceive the yellow as very bright and the blue as dark because lightness in HSL doesn't really make sense from a human perspective. Also, because OKLCH is perceptually uniform, you can see that if we create a gradient, it looks much more smooth compared to HSL because it's based on how the human eye perceives colors. And our eyes are much better at detecting colors in the dark areas, which is why we perceive this gradient on the top as a smooth, gradual progression, even though there are more dark colors than light colors. This is the OKLCH picker from Evil Martians. As you can see, the numbers there are a bit different than what we're used to working with, for those of you who haven't tested out OKLCH yet. But what we are doing in our team is that we are normalizing the colors that we use. So we have this moss green color, which is the accent color in the EDS. So instead of using OKLCH values with a lot of decimals, we try to find the nearest color that looks good, but that's easier to work with. Another thing that's great with OKLCH is that it supports the P3 display P3 color gamut, which is what we have on Macs and iPhones and iPads and so forth. Some PCs do. They don't support display P3, but a similar color gamut. And display P3 has, or OKLCH has, about 50% more colors than what we have on in RGB. So that means that if you are using colors on a product that's going to be displayed or used on, for example, Apple's devices, then you're missing out if you don't use OKLCH. Because if you use HSL, you have a map that only covers about 67% of the landscape. There is no way you can get to those extra vibrant greens and reds using that map. You have to use OKLCH to get there. So in this case, if I turn on P3, you can see that we get more colors. Another thing that we are doing is that we're using APGA, as I mentioned. APGA is a more advanced color contrast algorithm compared to the one we have in WCAG. It's based on human perception, just like OKLCH. And one of the principles of APGA is that luminosity is king. When you see a picture, like the picture of the parrot, it takes about 70 milliseconds before you see the colors, because the first thing you see is actually the contrast, or the grayscale. So that's also why in the EDS, we have a color system now where in Figma, you basically add the colors in grayscale first. And then you add the colors as a second step to force designers to be more conscious about contrast. We have user tested it, so I think we're pretty safe. Or to put it another way, we user tested 2 different systems, and we ended up releasing both of them. Because the system that I believe in wholeheartedly, where you have to take those 2 steps to add a color, we know that that's a bit different from what people are used to, and we know that it's going to take some time to convince people, right, that it's a better option. So another difference, or one difference between APGA and the WCAG contrast algorithm is that you have these new scores that you need to pay attention to. So for example, LC90 is what you use for body copy, which means lightness contrast. And then as you can see, we have different values for body copy and labels and so forth. For those of you who have tried APGA and think it's too much or too hard, there is also an intermediate step that's nice to know about, which is called Bridge PCA, which is basically fixing the problems that we have with the current contrast algorithm in WCAG, which is specifically in the yellow and orange hues, and also that it doesn't really work with dark mode. Basically because it's based on CRT technology from 1988, which was perhaps before dark mode became a thing. But if you care as much about readability as you care about compliance, then I would argue that APGA is a better choice. That does not mean that we should forget about WCAG and not use that at all. But I think if you need to meet WCAG requirements, if you have public-facing websites, for example, things like that, and use the WCAG contrast algorithm first, and then fine-tune it using our APCA afterwards. Then you are guaranteed that you have optimal readability. So this is the color system that we have created in the EDS. As you can see, we have these 15 steps. This is a semantic color system, meaning that instead of a natural progression from light to dark, every step in this scale has a specific role in the system. So in this case, we have the canvas color to the left. Then we have the surface color, which is anything that's on top of the canvas color. And then we have the background color, a light background color with a hover and press state. And we have a dark or more pure background color with a hover and press state. 3 border colors, and then we have text colors that are meant to be used on top of those background colors. So low contrast and high contrast on top of step 3, and low contrast and high contrast on top of step 9. And then we are using APCA to calculate the scores. So here you can see that in this case, if you use this text color on top of step number 1, 2, or 3 over here, then we are within that requirement, that 90 LC90 requirement. This system, this color palette, is available for anyone who wants to take a look at it, take it for a spin, see if you can use it yourself, and you can download the colors in World Wide Web Consortium token format, the design token community group format. Yeah, and another thing that we're also doing is that we have a Gaussian curve for the saturation, because we want more saturation in the midtones and then less saturation in the light tones. So in order to do that, we have this system where you can play around with the saturation. And we have a nice visual too. If I can zoom in a little bit, then you can see how that affects the color scale, right? So in this case, we get more saturation in this part of the scale, and then I can also change how wide this curve is. So by doing that, we end up with a color system where colors that are meant to be used a lot have less saturation, and colors that are meant to be used sparingly have more saturation. And this is what it looks like in this demo app that we are using. So this is light mode, and this is the dark mode. If you want to build something similar, I just want to show you briefly how you can do that. Because, and in this case, I'm not using the EDS colors. I've chosen some brighter colors deliberately. Because since OKLCH is perceptually uniform, that means that you can create these variables in CSS where you have a variable for the hue, right, which is the actual color in the color circle. And then we have fixed values, predefined values for lightness and for chroma or saturation. So that means that you can just drop in any hue you want, any color you want, and you get a new row. And you can even make it use a user preference if you want. And then, as you can see, all you need then for the actual color is to change the value of the hue variable, like that. So, in the case of these components, let's say I want an accent button, then all I need to do is this. Let's see, that was the chip, so I want an info chip. And this is the button. I want accent. So as you can see, if I change the chip color, let me just remove this debug for a second. If I change that color to something else, then I still have the same contrast between the text and the background, the icon and the background, and so forth. That is consistent, which is the beauty of having a system like this. So going back to this popover component that we looked at briefly in the beginning of the talk, this is what that would look like using this color system, where we have a hover color and yeah, the same for the close button as well. All right.